This is question 7 from exercise 6.4 in Project Maths 2. In part 1 we are being asked to solve the equation x squared minus 8x minus 84 is equal to 0. And in the second part we're going to ask to solve the equation t squared minus 5t all squared minus 8 times t squared minus 5t minus 84 is equal to 0. Now for this, as part ways of using this as an explanation, we're going to look at part 2 first. So in part 2, if we try to solve this out as it is, we need to multiply the brackets to start with. And if we multiplied out these brackets, t squared minus 5t all squared would become t to the 4 minus 10t cubed minus 25t squared. And then if we multiply the 8 in, it's going to be minus 8t squared plus 40t, and then we still have minus 84 down the end. That's equal to 0. And if we tidy that up a bit, we get t to the 4 minus 10t cubed minus 33t squared plus 40t minus 84 is equal to 0. And this is not something that has an easy method for factorization. So instead of trying to jump straight to that, which we're just going to put a pin in now and leave it aside, instead of doing that, what's far easier to do is to take the equation that we start with, which is what we've got here in part 2, just here, and we're going to substitute out from brackets. We're going to put x in instead. So instead of t squared minus 5t all squared, we're going to put in x squared. And instead of 8 times t squared minus 5t, we're going to put in 8x. And then we're just going to leave our minus 84 on the end, equal to 0. So in other words, what we're saying is that t squared minus 5t is equal to x for the sake of our substitution. And we'll see why we're going to do that in a minute. So we're going to factorize this out, which is in fact what we've got in part 1 up here. When we factorize this out, we're going to get x and x. And then we're going to have minus 14 and plus 6 still equal to 0. So we're going to get x equals 14 and x equals minus 6. And the reason that we've done this is that we can now take these two values for x and use our substitution equation over here and set t squared minus 5t equal to them. So what we get is t squared minus 5t equals 14, and we get t squared minus 5t equals minus 6. And now these are factorizable. So we're going to bring our 14 over, so we get t squared minus 5t minus 14 is equal to 0. Now we're going to factorize that out. So it's going to be t, first term of both our brackets. And then we're looking for factors of minus 14, that's sum to minus 5, so we're going to say minus 7 and plus 2, which means we get t equals 7 and t equals minus 2, like that. And then for the other equation, we're going to bring our minus 6 over, and we get t squared minus 5t plus 6 equals 0. And if we factorize that out, we're going to get t minus 3 and t minus 2. So t equals 3 and t equals 2. So we end up with 4 different values for t, which, if we think back, is kind of what we're expecting. When you've got a square as the highest power in your equation, you get 2 values out. But we saw that when we multiplied out these brackets before, the highest power for t was 4. So we would be expecting to get 4 different values out for t in this, which is exactly what we've got down the bottom. And that is that.